difference between augmented reality, virtual reality, and mixed reality. It is a range of experiences. On one hand, we have virtual reality, which is a total immersive experience where you put on a headset and you are disconnected from your environment. Everything you see and interact is a 3D generated object. And on the other hand, for augmented reality, you have a connection to your environment, like in HoloLens, and you have some extra information, maybe 3D or maybe audio information that's available to you, which is augmenting your reality. Also, we have mobile phone applications like Pokemon Go. You are looking through the glass of your phone and you're able to find 3D objects in the real world. And this whole range of experiences we call mixed reality. And short, it's called XR.
So we are live again in this XR conference. In this stream, Bruno Vanini is going to do a presentation on the ATON framework, and Bruno is going to introduce himself.
So, hi all, welcome to everyone. So I'm Bruno from CNR ESPC, that is the Institute of Heritage Science in Italy. We are located in Italy. I'm a PhD in computer science, and my activities are mostly focused on research and development on the in the interactive 3D field. So with special focus on immersive VR, Web3D, WebXR, and web-based tools and services targeting the cultural heritage field. So today we are going to talk about the ATON framework. Before that, just a quick overview of what we can achieve today through the web, and especially through our web browser. If we see the recent advancement of 3D presentation, you can see that there have been a lot going on recently. We are seeing here a video of a 3D presentation on the Sketchpad platform. And as you can see, the presentation are reaching levels that we never see before. We've seen real-time refraction and advanced effects that are that we can see through a simple web page using a common browser. On the other hand, we have a WebXR specification that is basically allows us to present immersive VR content and also augmented reality content using a browser. So once again, without any kind of installation required for final users. And then we have also, we have seen that in the recent years, we have a tighter and tighter device integration of our web browser. So for instance, a web page or a web application can access, after user consent, of course, can access microphone, camera. So we are talking about desktop computers, mobile devices, and so on. So mobile devices, for instance, we can access GPS, device orientation, compass, and much more. Then we have, thanks to WebXR, we can present 3D content online directly using head-mounted displays, also ranging from low cost like cardboards up to high-end devices like Oculus Quest, for instance, including also VR controllers, so with 6 degrees of freedom, and also recently hand tracking, so you can actually use your hands to interact with the content that is directly living inside the web browser. So in this case, if we think about all these ingredients in perspective, targeting cultural heritage, we can see that we can create and craft 3D experiences and applications that actually do not require an installation for the final users. We don't have to deal with the app stores and also all the review processes that are behind an application that you want to publish through an app store. And then we can also reach cross-device consumption. So that means that we can basically create some kind of web application that reaches every device, ranging from mobile to desktop, laptop, up to immersive VR devices through WebXR. So it is clear that all these things together, perspective, represent an incredible opportunity for museums, institutions, labs, professionals that are working into the cultural heritage field. Of course, we have some challenges. There are several challenges, of course. Here, I want to highlight 3 of them. In particular, the first one is related to the transmission of 3D models, 3D assets. Of course, because especially in cultural heritage, we have to deal with quite complex assets and data sets that need to be streamed to client devices. So they can be very complex in terms of geometry and texturing. So this is one of the challenges. Then we have another challenge that is related to the limited resources that we have on web browser, especially those on mobile devices, including low performances and also graphics performance. Then we have a third challenge that is basically related to interaction models that can be very, very different among different devices, of course. If you think about it, when we interact to mobile devices, we have an interface and interaction model that is designed for multi-touch interaction and multi-touch devices. That is completely different from desktop computer or museum kiosk, and is completely different from the interaction model that you have on head-mounted displays, including controllers and also different degrees of freedom. So here comes the ATON framework. That is an open source project. It's on GitHub. Later you'll have the link. And it's basically a framework that allows you to craft and create a liquid Web3D WebXR application. By liquid, we mean that once you create your web application, it automatically is deployed on, and this can be consumed on different devices, ranging from mobile to desktop to head-mounted displays and so on. So it's actually a unique effort that you made, and then you have something that can be reached on every device. The framework is designed for being very easy to use and also very easy to deploy. We'll see later some scenarios. It's multi-user, so that means that you have different users that can authenticate on the framework and create scenes and so on. But more importantly, is designed around modern web standard. So these are a few examples of web standards embraced by the framework, also including some libraries that ATON is based on, like 3JS. It is a very large library with a very large communities. Then on the service side, we have the embracement of Node.js, that is one of the largest open source ecosystem to create scalable network applications, and also several components and open source libraries related to Node.js. So let's have a look at the 3D content that we deal with into the framework and their standards. So in ATON, the main standard for delivery 3D content is, of course, the GLTF format. This standard that is widely adopted nowadays. It's designed for the web, and also is becoming more and more easier to actually to create and export 3D content for this format. So you can see there are a lot of tools, a lot of software and application that allows to very smooth content creation workflow to create and publish this kind of format. It's also very interoperable and reusable. For instance, Sketchfab platform allows you to directly to download 3D models in using this standard. And also recently, Smithsonian, for instance, published open access collections, entire open access collection using this standard. So another important point, especially for cultural heritage, is that the GLTF allows you to present using physically based rendering. That means that you can have a more accurate simulation of materials. Like in this case, you can create this kind of assets that react consistently to different lighting setups and lighting conditions, so you can test out different hypotheses and different scenarios for your museum collection. We embrace latest Cron's extensions, including real-time refraction. Here we are looking at some augmented reality examples with physically based materials. So in general, it's this kind of pipeline is consistent not only with virtual environment, but also physical surroundings if we are dealing with augmented reality like shown in the video. Always, of course, embracing the WebXR standard. In ATON also, we have the possibility to have a more advanced setup with several light probes that allow you to simulate more consistently the response of the item to local surroundings. So as you can see in these images, there are 3 different instances that react consistently to their surroundings. And this allows professionals and museums to create very advanced 3D presentation directly on the web. If we are dealing with more complex assets, we embrace another standard, this the CSIM 3D tiles, that is basically designed for streaming and rendering massive content online. So it's multi-resolution. So it is specifically designed for photogrammetry. This is pretty common in cultural heritage, point clouds, and so on. In ATON especially, there is also native support for WebXR. So you can actually use your headset and explore really, really complex 3D models and 3D assets. Like in this case, we are exploring the Dingo Gap from NASA. And this is possible thanks to an integration of another open source library that is called 3D Tiles Rendered, developed by NASA. So let's have a look at the data organization of the framework. We have here an important distinction between collection and scenes. Collection are basically where you create your items, 3D models, tile sets, like we've seen 3D tiles, 360 panoramic content, audio, and so on. On the other hand, you have the scenes that are basically possible arrangements of these items. So the scenes are can be published inside the framework, and they have a unique identifier. So you know that when you have the identifier, you have a specific scene. They are very light in terms of storage because they are basically JSON descriptors. And this separation leads to several advantages, because you can actually, with this approach, you can reuse the same item in different scenes. Let's say you want to test different scenario, different lighting setups, and so on. You can reuse the same item in different scene. It's very easy to update one item because basically once you update the item, all the scenes that refer to that item are updated. You can clone a scene, and also a scene can have a reference to external resources, so you can actually mix together items from local collections, remote collection, and remote items that are far away in some other server. So basically, in general, from user side, you can log in to the framework. You can create your own 3D scene starting from your collection. And then if you like the scene, you can, of course, make the scene public. So that is visible in the main gallery. This is basically the landing page of the framework. And also the landing page provides some searching capabilities using keyword user or term that allows you to filter content and filter scenes if you have several of them. Let's have a quick look to the basic interaction that you have built into the framework and tools. So especially for navigation, of course, there are already built in some interaction models, as you can see here in the video. The navigation system is, of course, cross-device, so it automatically adapts to different device. And you have first-person navigation, orbit mode, device orientation mode, and so on. And as you can see, there is also the possibility to have immersive VR exploration through WebXR. And this includes also 3 degrees of freedom and 6 degrees of freedom devices. Then you have also a possibility to add viewpoints, of course, to a scene, and also add custom constraints. So if you want to add some limits to what the user can navigate through or where he or she can move around. In this case, we have also seen some other built-in feature that regards semantic annotation. Like in this case, you have some very easy to use tools that allow you to annotate and add some rich content, in this case is HTML5 content, to any semantic shape into the scene using different devices. Then we have the possibility to add measurement into the scene. In this case, it's a tile set that we are adding some measurement. And then we have also a spatial UI. That is basically interface elements, 3D interface elements, especially designed for immersive VR experiences. So they are very useful in this case, like we are seeing here in the video. we are actually annotating directly using an head-mounted display. So once again, here there is no installation. We just opened a browser and we are using these tools directly to annotate, add measurement, and so on. So all these features that we are looking here are basically also driven by cultural heritage communities, and also comes from previous experiences and projects that we have in our laboratory, and they also come from user feedback. So they're actually helping us a lot to add and refine all these tools that we have seen. Then, of course, into the framework, another important aspect is that we have built-in real-time collaboration. That means that different people and remote users in this case can access and interact together into the same session, into the same scene. And this is valid for also local network. If you have, for instance, a local access point without internet connection, for instance, or in a worldwide context. So basically, different people, possibly very far away, can access and interact together. This is a concept that is already seen and quite similar to Mozilla Hubs, but in this case, this is specifically designed for cultural heritage. So as we'll see, there are specific tools, specific functions that are designed for this specific field. So basically, when there is one user that just using a simple button can connect to a session, if the session is not there, it is automatically created by the framework behind the scenes. So once there is an active session, other users can join the session using completely different devices. So we are talking about tablets, a smartphone, once again, head-mounted displays, computers, and so on. And each user is assigned a specific color. Here we see some example in this video. So in this case, the session ID is basically the same as the scene ID. So as you can see, we are working together with other people. And as you can see from the video, there are some specific tool that works in a collaborative environment, like annotations. We can see here, you can switch on and off different layers. This is very useful if you want to, during, for instance, teaching or classes that you want to show or hide different portion of the scene to other participants. And this is possible thanks to the possibility that inside the framework, all these modifications are broadcast. So basically, when you change or switch layers of the scene, you change lighting, you add or remove annotation measurement, they are automatically synced with and broadcast to other participants. This collaboration component is also can be extended. So if you have more custom logic that you want to adopt, you can extend the component very easily. There is an API specifically for developers for doing that, and so you can actually create your own system and your own specific logic for WebXR application or Web3 application. So specifically like chat systems or collaborative experiences for cultural heritage or applied games, for instance, custom teaching tools, WebXR tools also. So it's pretty much very extensible. And then I'll leave you also the links to the API, but it's very simple. And then speaking of extendability, the framework also allows plug-and-play architecture for web application. That means that you can very easily create your own web application, your own that can be a tool, can be an experience, can be a specific applied game for cultural heritage. You can build your application on top of all these features that we saw in the previous slide. And you can actually plug in into the architecture very easily. This is because museums, institutions, and professionals may have different requirements in terms of user interface, behavior of the application. So this is to give all the freedom to developers to create custom experiences, custom tools for cultural heritage. Then each of these applications are also have a unique identifier. So just like the scenes that we saw before, and also provide a familiar environment especially for 3JS developers, because ATON, as we saw before, is based on 3JS. So you have also a familiar environment to develop this kind of web application. And the framework also provides you a built-in front-end and back-end, namely they are called ATON and SHU. So this allows museum and also other stakeholders to use this built-in front-end and back-end, or if you want, you can actually create your own and extend your own application. So here we see some examples of a custom web application built on top of ATON framework. You can see games. Here we can see some specific interaction models, like in this case is called temporal lensing, which is basically very nice possibility to discover another layer, that is another layer into the past, into the future. Then we have the possibility to create, in this case, professional tools for semantic inspection. And then we have also possibility, in this case, to create visual or immersive analytics tools. So basically, they are very useful, once again, using a normal web browser to inspect previously captured user sessions. So this is just some examples of what you can create on top of the framework, of course, also targeting cultural heritage. So speaking of deployments, where we can actually deploy our instance of ATON, as you can see from the scheme, it's actually pretty flexible, both in terms of hardware and also scenarios that we have. So in terms of hardware, the deployment range from, you can actually use very low-cost devices like single board computers like Raspberry Pis, up to laptop, workstation, PC, then small server to a laboratory, up to a large infrastructure. Or even go there beyond and use cloud computing services like Amazon, Google, Microsoft Azure, Heroku, and much more. Pretty much everything that supports Node.js. So pretty flexible in these terms. Then for scenarios here, we have basically three possible scenarios. The first one is a very basic one. As you can see, the green represent the physical location of our ATON framework, so including web application and 3D content. In the first case, they overlap. So basically, you can imagine a museum kiosk without any kind of internet connection, any kind of local connection, that is basically running and people consume on the same identical device. Then we have an intermediate scenario where you have an access point or hotspot and with a local Wi-Fi network, for instance, where people can connect and access, consume all these web applications and 3D content directly using their own devices. Or we have the third scenario where we are dealing with worldwide and worldwide level. So you have people that are consuming your web application, your 3D content, your experience, possibly from far away, from different nations. So to sum up the what we saw into this slide, ATON is basically an open source framework that allows to craft and create this kind of liquid Web 3D WebXR applications. The framework is designed around modern web standards like GLTF, Cesium 3D tiles, WebXR specification, much more. We have some presentation feature, especially focused on cultural heritage presentation. So we embrace the physically based rendering workflow. There are some advanced functionalities for creating multiple light probes, so creating very nice and advanced setups for lighting. We have post effects and so on, mostly coming from the 3JS open source library. We have seen that we have some built-in out-of-the-box features and tools, especially designed for cultural heritage, like measurement, semantic annotations, special UIs, and so on. The framework offers you real-time collaboration that enable, in turn, to have some kind of WebXR discussion spaces, classes. We use this tool actually during the pandemic, for instance, to have some courses with students connecting and discussing together into these 3D spaces related to cultural heritage. You can imagine multi-user experiences, applied games using this collaboration component. And this basically gives you some also building blocks to create CH metaverses, of course. The deployment, as we've seen, is pretty flexible. So you can have different scenarios and also different hardware, ranging from low cost to higher pricing. So this is very useful also for very small, small museums that may cannot afford some kind of hardware. So you can use a low-cost hardware to deploy your experience to your web application. The framework is easy to extend thanks to this plug-and-play architecture for custom applications. And then the framework also offers a REST API that basically allows an easy integration with external or existing services and infrastructures. So I can end here. So thank you for the attention. Here you can see some of useful links regarding the ATON framework, API documentation, and also there is Telegram open group. So thank you.
Thank you, Bruno, for your presentation. We have one question from the audience, and that question is, I'll simply read it as it says here. What would you say is the best feature of ATON in comparison to other frameworks?
So in general, we have a combination of features that are basically designed for cultural heritage. I think the most prominent features are related to real-time collaboration combined with multi-resolution adoption using the 3D tiles by Cesium, and the possibility also to explore together this kind of complex data sets using also head-mounted displays. So this is thanks to the combination of different standards and different open source library.
Okay, thank you. So I have a question myself. So because it's about cultural heritage, is there a limit to the size of the 3D models or the files that you actually load and work with? Or is that something that you take care of if these files are extremely big?
In general, if we are dealing with museum items, we can just use the GLTF format. And then, as we saw to the presentation, for much complex data sets, you can use 3D tiles format. This is actually standard. This is also gaining more and more attention recently with the new specification, and it's very promising because actually it allows you to explore interactively very, very complex environment, and actually also to a planet level. So it's a very promising direction that we are exploring, and especially combined with the head-mounted displays. This is thanks to the NASA library that we saw into the slide.
Okay, so and you've been doing this for a while, I guess, because otherwise the toolkit would not be this complete, basically. But if you look at the future, is this something that you keep on pursuing? Is this going to be something that you are going to be doing in the next couple of years, or is this a project that at some point is going to end?
Actually, there are several projects that are using the framework. So all these projects also provide very useful feedback. So it's very important for us to actually to collect this feedback and improve all the functionalities. Like we saw in one of the slides, there are some of the features are actually driven by the community. So they are basically helping us and guiding us into adding specific feature targeting the cultural heritage field. So, but in the future, what I see is that it's very promising. Like I said, especially in WebXR. So I'm talking about immersive VR but also augmented reality, because WebXR is unification of both worlds. So what I see is that it's very promising in this term. So combined with the possibility to the important piece of the puzzle that is you don't actually have to install anything. So for visitors, for common users, they basically do not have to install anything on their device. So this is something that we have a lot of positive feedback during all this recent projects, but also previous projects.
Sounds great. I don't see any other questions in the chat. So I want to thank you for this very nice presentation. Very interesting to see what is happening there. And
thank you.
Yeah, I'll be ending this stream after we actually leave it. So thank you again, and
thank you, Rudy. Bye.
Bye.